Okay, so we are going to start chapter 2, which talks about chemistry. So, question for you. What do you think about the chemistry? Why do we have to study chemistry in human anatomy and physiology class? Anybody has any answer? Body is made up of molecules and chemical reactions in our body. Anything else? Yeah? Cells. Anybody else has any other answer? Okay. So you guys gave me like really some good points. You guys are correct that your body is made up of what? A lot of chemicals. And if you ask me, your body is actually what? Your body is facilitating more reactions than actual chemical laboratory. Everything you have in your body, the reason you can write, the reason I can speak, the reason I can metabolize the food, digest the food, generate the energy, utilize that energy, everything is happening because of all the chemical changes that are happening inside our body. First of all, our body is made up of the what? A lot of chemicals, right? So that is the reason we do have to study chemistry in our human anatomy and physiology class. So as you have told me, chemistry underlies all physiological reactions, including your movement, digestion, pumping of heart, nervous system. So when we talk about the chemistry, we can talk about chemistry in two different ways. One is the basic chemistry, right? When we say basic chemistry, what do we mean by that? How, like your elements, molecules, chemical reactions, chemical compounds, these are all just basic chemistry, okay? But when we say biochemistry, what do we mean by that? We are only talking about the chemicals that is happening inside your body, right? Inside in living organism, right? Okay, so first we're going to start with the basic chemistry. So when we start with the basic chemistry, the first thing probably we need to understand is the basic word like energy. When we say energy, what do we mean by that? So for example, as you can see right here, I am walking. When I am walking, what I am actually doing? I am using energy to move, right? So if you want me to define energy, I would probably tell you it's the capacity to do the work, right? Now, if I tell you that she also has energy, are you gonna believe me? Yes. Why? Because you know that she can actually stand up and walk like me, right? What does that mean? It means that when I'm walking, my energy is in use, and when she's sitting down, not using right now, but she can still stand up and actually walk. What does that mean? It means she does have the potential energy. The energy I'm using right now, what do we call it? Kinetic energy. The energy she has, she is not using right now, we can call it potential energy, right? So now you understand what does it mean by the kinetic and the potential energy. So now let me ask you some question. So for example, let me ask you a question before I tell you. So does anybody here want to share with me what did you eat for breakfast today? Huh? Nothing? Nobody? Anybody ate anything? Huh? A bagel. Very good. So she ate a bagel. Okay. So have you ever seen bagel before? Everyone? Yeah, saw bagel? Okay. So when we say bagel, when we see that, what do we see? It's a bagel, right? But why do we actually eat that? And what is happening to that bagel when we eat it? Breaking down. So basically, what is happening when we say a bagel, bagel is probably has a lots of carbohydrate, right? So lots of carbohydrate, maybe a lot of starch in there, right? So it's going, when you are eating that, by the digestion, what you are doing, you are breaking it down. You are breaking down the starch to make it to glucose, and then your body absorb the glucose, and then glucose goes to the what? Cell, and then in the cell, by using the cellular respiration, you are converting the what? Glucose to ATP, your energy, right? So every steps that I told you, these are all basically the what? Chemical reactions. And those chemical reactions are generating ATP from the bagel she just ate. So that bagel is actually, whenever we are looking at the bagel, we are actually talking about the what? Carbohydrate in there, right? Again, a molecule, a chemical molecule. So one thing I want you to understand here, when you look at that bagel right here, do you think, does it have any energy? Anybody thinks it has any energy? It has potential energy. Very good. It does have potential energy. That potential energy is actually what? Stored in the where? That potential energy is stored in the what? If you think about the starch, when we say starch, like for example, if you think about the starch right here, what is happening? We are trying to break it down to glucose, which is C6H12O6. This is the glucose which is going to your cell so that you can generate the ATP from there, right? That is the cellular energy that you are going to use to do all the function in your body. So what does that mean? That chemical energy it has, this is basically the what? A potential energy. The chemical energy is what? A potential energy. So now there are so many different types of the forms of the energy we have. I just talked about the chemical energy, but right now you do see a lot of light energy, right? And you see the electrical energy, which results from the movement of the charged particles. And what about the mechanical energy? Everyone came here by a bus or a car or whatever, right? These are all what? Possible by the mechanical energy. And there are radiant and electromagnetic magnetic energy, right? Heat, visible light, UV rays, X-rays, right? So there are different form of the energy. But one thing I want you to understand about the energy is you can actually what? Convert one form of energy to another form of energy. Like for example, in this chemical energy we have in the glucose, we can actually convert it to what? Maybe I'm moving right now, right? But every time you are actually converting the energy, one form of energy to another form of energy. For example, if you think about the electrical energy, what? Converted into light energy. But if you actually hold this light on top, you will see it's like very hot. The reason it's hot, because while you are converting the electrical energy to the light energy, some of the energy is actually what? Getting lost as heat. So yeah, you can convert energy, but that conversion is not 100% efficient. Yeah. Okay, so now let's talk about the atoms and elements. But before I talk about that, I want to make sure that you understand something very important, which is when we say matter, these are like maybe grade 3, grade 4 type of questions. So when we say matter, what do we mean by that? When we say matter, yeah, very good, very good. Everyone knows the answer. So when we say matter, what do we mean by that? It has mass and it occupies the space. And we know that we have like how many different types of the matter we have? Different stages, phases of the matter, right? We have solid, liquid, and gas. Okay. So I just wanted to make sure that everyone is with me. So one thing I want you to understand, all the matters you see in this world, all the matters you see in this world are actually made up of the what? Elements. All the matters are actually what? Made up of the elements. Do you know how many matters we have in this world? Unlimited. A lot, right? We have a lots of different matters, and those are all made up of elements. So when we say elements, do you know how many elements we have? We have unlimited number of matters, but do you know how many elements we have in this world? Huh? 7? Have you ever seen the periodic table? Huh? How many? 118. How many? 118. So now if you look at this 118 elements, these 118 elements are getting combined with each other by different ways to actually make that unlimited number of matters, right? Now, these 100 elements, before I talk about these 100 elements, let me talk about the definition of the elements. So when we say elements, what do we mean by that? Atom. Sorry? Um, Element is the smallest part of any matter. It cannot be broken down into substances. Anybody else want to say anything else? So you guys are all right. You guys are going kind of talking toward the same direction that I'm gonna take you to. So she's saying that you cannot break it down to any other substances. So let me just talk about that in this way. Like for example, I'm wearing this gold chain right now. This gold chain is made up of what? Gold. And gold is what? An element. Why we call this gold an element? Because when you break down this gold, you are only gonna get what? Gold, right? You are only gonna get gold. But what if I tell you that the water right here, is this an element? No, it is not an element, because if you break it down, you're gonna get hydrogen and oxygen, right? Like the carbon dioxide we are breathing in, do you think it's an element? No, because if you break it down, you're gonna get the what? Carbon and oxygen. What about the oxygen you breathe in? That's element, because when you break down oxygen, you are only gonna get the what? Oxygen. So now is it making sense in your head? When we say element, what do we mean by that? When we say element, what do we mean by that? It means that we are talking about something, when we break it down, we are only gonna get the same element, same thing, right? But when we say matter, what do we mean by that? Or compound or molecule, you can break it down and you're gonna get the what? Different elements. Okay. So now we know what do we mean by the elements. So some of the examples of the element right here, let me just read it for you. You have your hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, then aluminium, silicon, phosphorus, sulfur, chlorine, argon, krypton, xenon, radon. The reason I read some of this to make sure that you understand how to actually what is going to how do we write about the elements, right? So now let's talk about it. So for example, if we say elements, so how do we actually, what is the symbol of the element? So a lot of the time when we say symbol of the element, what does it mean? So we are like, how do we, what is the symbol of hydrogen? H. What is the symbol of helium? He, right? What is the symbol of sodium? Na. Why Na? Why not S? Because it's coming from the Latin name, right? Natrium. What about the potassium? What is the symbol of potassium? K. It is coming from the Latin name kalium, right? So what I am trying to make sure you understand that the name, the symbol is not only coming from their English name, but also from the what? Latin name, number one. And number two is like, if you see with one letter, you already have one atom, one element, what are you gonna do? For the next one, you have to take the first two letters, right? Hydrogen, H, and then helium, He. Clear? How to, what is the symbol of the element? Okay. So now the reason we are talking about the element is because when we say, we only care about our human body right here, right? So when we say our human body, do you know what are the most abundant elements in our body? 96% of your body is actually made up of 4 elements. And what are the names of those? Carbon, oxygen, hydrogen, and nitrogen. 96%. 96% of your body is actually made up of how many elements? 4 elements. What are those? Carbon, hydrogen, oxygen, and nitrogen. Okay, so there are other elements, like 9 elements make up the 3.9% of the body, and there are 11 elements that make up less than 0.01% of the body. Like, can you give me some example? Like if you think about your hemoglobin, what is the element which is the very important part of the hemoglobin? Iron, right? If you think about your bone, what is the most important mineral in your bone? Calcium, right? So you can understand what do we mean by that. These are the main: carbon, oxygen, hydrogen, and nitrogen are the 96% of the body, but other 9 I could say, like other 20 elements that you also need in your body to do the proper function, right? As I told you, I already gave you some example, like iron, like calcium. Like, have you ever, do you know which element do you need for your thyroid function? Iodine, right? And there are zinc, manganese, cobalt. You do need those as a cofactor for enzyme function. Okay. Okay. So now when we say elements, we also have to talk about atoms. So when we say atoms, what do we mean by that? What is the definition of atom? So we know that you can break down what? Element. Like, for example, if I am thinking about my gold chain, the gold chain is made up of so many golds, right? When you break it down to this point, after this you cannot break it down anymore. That is called the what? Atom. So atoms is basically the what? Structural unit of the smallest unit of the elements. Okay. So now let's talk about the atom a little bit more. So you can actually break down atom, but you need to think about how much you can break it down to the level where you can still retain its chemical properties. Okay. When after you break it down to a point where it does not retain its chemical property, we do not call it atom anymore, right? until you can break it down to the point where you cannot break it down anymore, retaining its chemical property, you call it atom. I talked about the atomic symbol already. So now let's talk about when you break down atom, what do you get? When you break down atom, what do you get? Do you, proton, electrons and neutrons. So when we say proton, electron and neutron, so for example, if you think about your atom has a nucleus. In the nucleus you have the what? Proton, neutron, and here you have the what? Electron. Okay, so you have electron, proton and neutron, okay, in the atom. So now let's talk about the name and charge of all these different subatomic particles. So when we say proton, proton is present in the nucleus. What is the charge of the proton? Positive. What is the charge of neutron? Neutral, no charge. What is the charge of electron? Negative. Very good. Okay, so I did talk about that already. Proton, neutron, electron, and then what is their charge? So now let's talk about something very important. Let's look at the periodic table one more time. So when you look at the periodic table, you will see that hydrogen 1, helium 2, lithium 3, beryllium 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, neon 10. The numbers you see right here, these numbers are actually what? Identifying numbers. Do you know what is this number actually? This is the number which is the number of proton. Number of proton. So the number of proton is actually like the identifying characteristics. Like for example, if what's your name? Kushi. So her name is Kushi, right? So is there any other Kushi in this room? No Kushi in this room. So Kushi is her what? Identifying character. So identifying name, I would say. So now if I call Kushi, who's gonna raise your hand? Only her. Is there anybody else who's gonna raise your hand? No. Like that, in your atom, you have total 118 elements, and 118 elements has how many, what is the identifying characteristics? Their atomic number, their number of protein. I already told you the number of protein is also called atomic number, and the atomic number is the what? Identifying character. Okay. Okay, so what does that mean? When we say atomic number 1 or proton number 1, there is only one element, which is hydrogen. When we say atomic number 2 or proton number 2, there is only one element, which is helium. If it is 3, it's lithium. If it is 4, it's beryllium. 5, boron. 6, carbon. 7, nitrogen. 8, oxygen. 9, fluorine. 10, neon. Clear? Okay, good. So now we know about the atomic number, which is actually the number of proton, right? So now let's talk about the neutron number and the what? Neutron number and the electron number. One thing let me tell you about the neutron number is, even though whenever we are saying hydrogen can only have proton number what? 1. You cannot change that. If you change the number of protein, hydrogen is not gonna be hydrogen anymore, right? However, hydrogen can have different number of the what? Neutron. Okay, hydrogen can have different number of the neutron. So now let's talk about that a little bit more. So when we say atomic number, what do we mean by that one more time? The number of proton. Very good. And where do we write the number of proton? The number of proton or atomic number, we usually write it as a subscript. Okay. And then when we say mass number, what do we mean by the mass number? Mass number is basically the total of your number of proton and the number of neutron. Okay. So, as I told you already, that if you change the number of proton, the name of the element will also what? Change. But if you change the number of neutron, what is going to happen? Is it going to change the name of the element? No, it is not going to change the name of the element, right? Okay. So now I want you to understand right here another term, which is isotope. Have you ever heard of the term isotope before? Yeah, yeah. So a lot of you probably wants to become a radiologist or something like that. So in that case, you probably have to use a lot of radioisotope, right? So when we say isotope, what do we mean by that? It means that definitely proton number doesn't change, but neutron number change. Whenever you have the different number of what? Neutron, then you call it isotope. Like for example, hydrogen does not have any what? Neutron, right? But there is another form of hydrogen which can have one neutron. There is another form of hydrogen which can have two neutron. So in that case, we call them isotope of the hydrogen. Does it make sense? Okay. So now let's talk about, we did talk about the isotope and then atomic weight. When we say atomic weight, average of the mass number of all isotope form of an atom. So as you can see in this example right here, in this hydrogen you do not have any neutron. This one you have one neutron, this one you have two neutron. Okay. Okay. So now let's talk about the molecules. Does anybody have any question about the atoms and elements? Electron number, proton number and neutron number? One thing I did not tell you about the electron number, which is very important to understand, is like for example, if you look at this periodic table right here, when we say hydrogen has one proton, hydrogen also has one electron. Okay. In the normal condition, all the elements have the same number of electron and the same number of proton. So hydrogen, if hydrogen has one proton, how many electron does it have? One. If neon has 10 proton, how many electron does it have? 10. If argon has 18 proton, how many electron does it have? 18. Okay, very good that you make sure you understand. So now let's talk about the molecules and compounds. So when we talk about the molecules and compounds, one thing I want to make sure that you understand, that we only have 118 elements, and these 118 elements are actually getting together in so many different ways to make all the unlimited number of matter we have. Yes or no? Yeah. So when you combine the what? Different elements together, you make the what? Compound. And when we say the smallest unit of compound, what do we denote? Molecules. So the smallest unit of the what? Compound is the molecule. This is kind of easy to understand, right? So the glucose, example of the glucose, what do we see? 6 carbon, 12 hydrogen and 6 oxygen together make the what? Glucose molecule, right? Okay. So now let's talk about the chemical bond. Okay. So first of all, I want you to understand something very important here. We know that we have 118 elements. These 108, we only have 118 elements, and then we are making what? Unlimited number of compound, unlimited number of matter. Why do you think these elements do not want to stay alone? Why they are like us, human being? We also do not want to stay alone, right? We want to make relationship. We hook up, we have what? boyfriend, girlfriend, at some point probably we get married, we have child, we make big families, so many relationships, right? So all these relationships are basically why we are trying to do that. Hmm? To be, to stay away, stable, to be stable. Yeah, very good answer. Yeah, to be stable, right? So maybe, like for example, for me it is not, alone it's probably not possible for me to pay for everything, so maybe I can get married to my husband so that we can both take care of the kid and we can both pay for our house, our car and everything, right? Something like that, right? So these 118 elements, they're also what, trying, and they're looking for the what, stability in life. So that is why they do not want to stay alone. They always try to what, get together and make relationship. Okay, okay, that is the relationship. We call it what, chemical bond. This chemical bond is made in where, in the different elements. Okay, our energy relationship between the electrons of the reacting atoms, and chemical bonds are not actual physical structure, and electrons are the subatomic particles that are involved in all chemical reactions. So they determine whether a chemical reaction will take place, or if so, what type of chemical bond is formed. So we are going to talk a lot about that. So now let's talk about the different types of the what, chemical bond. But before I talk about the different type of the chemical bond, I want you to understand something very important, which is the electron. So I already told you that when we say number of electron, how do we decide? Like for example, if you are talking about the hydrogen, how many electron hydrogen has? One electron. So if hydrogen has one electron, they can only have one electron shell, and this one electron is going to stay in the what, one electron shell. But if I am talking about sodium, sodium has how many electron? 11. Okay, if sodium has 11 electron, first sodium has what, 11 proton, right? And then sodium has 11 electrons. So in the first shell they can only have 2 electron. In the shell number 2 they can have 8 electron, and in the shell number 3 they can have what, 1 more electron. So total what, how many electron? 2, 8, 10 and 11, right? Okay, so one thing I want you to understand, that these electrons are staying in the shells. In the first shell you can only have how many electron? 2 electron. In the second shell, how many electrons you can have? 8. In the third shell you can have how many electron? 18 electrons. Okay, but you can go more if you have more, but for this class just know up to like shell number 3, it can hold 18 electrons. So these, the last electron shell is called the what, valence shell. The last electron shell is called the what, valence shell. So now let's talk about why these atoms are trying to make the relationship. Okay, first of all, think about us human being, why we are trying to make the relationship. Maybe a lot of the time probably so that we can share our resources efficiently, right? Or maybe we can support each other. Maybe it's just the transactional, right? Somebody's providing, somebody's doing the household work, right? So a lot of the things so that we can actually perform all the function in the world properly. But as a human being, we want so many things in life, right? We want a very good, beautiful house. We want a beautiful wife, or maybe handsome husband, or beautiful car. So many things, right? But in the elements, those elements, that 118 elements we have in the world, they are only looking for one thing. Do you know what is that one thing? Huh? Energy? Does anybody have any idea what is the one thing the uh, to have a full valence shell? To have a what? Full valence shell. Let me clarify it a little bit more. So if they have one shell, if they have one electron shell, how many electrons they can hold? Two, right? If they have one shell, how many electrons they can hold? Two. So what does that mean? So if they have one shell, they want their one shell to be what? Full. So for example, if you think about hydrogen, hydrogen has one electron on the shell, one shell. So they are just looking for what? Two electrons on the outer shell, right? But if they have two shells or more than one shell, they are always looking for what? To fulfill, to have at least 8 electrons in their outer shell. How many electrons in their outer shell? 8 electrons in their outer shell. And that is called octet rule. What do we call it? Octet rule. What is the octet rule? The atoms are trying to fulfill their shell with how many electrons? 8 electrons if they have more than one shell. And if they have only one shell, they are trying to fill it with how many electron? 2 electron. And this is called the what? Octet rule. That's all they want in life. That is the reason they are making all the unlimited number of relationship, unlimited number of what? Matter. Okay. So now let's talk about how does that work. So first of all, I want you to understand one more thing in the periodic table, which is, so hydrogen has one electron. So do you think it's stable? Not stable, because they want one more electron in the outer shell. What about the helium? Helium has one shell, and this one shell contain how many electron right here? 2 electron. Do you think helium is happy? Very happy. Helium is what? Very happy. Helium is not looking for anything else. Helium does not care about any relationship. Okay, they are like saint. I'm very happy with my life. Okay. Now lithium has 3 electron. So what does that mean? Their first shell is full and the second shell has how many electron? 1 electron. Not happy. How about beryllium? Beryllium has 2 electron on the outer shell. So now they are not happy because they need 6 more. How about boron? Boron have 3 on the outer shell. Not happy. Carbon has 4 on the outer shell. Not happy. Nitrogen has 5 on the outer shell. Not happy. Oxygen has 6 on the outer shell. Not happy. Fluorine has 7 on the outer shell. Not happy. Neon has 8 on the outer shell. They are happy. So that is why all these on this column right here, helium, neon, argon, krypton, xenon, radon, they are called noble gas. They are like saint. They do not care about the relationship. They are not looking for anything in life. They are happy with themselves. Okay. So that is why they are called what? Noble gas. Except this column, rest of the what? Elements in the periodic table are looking to fulfill the what? Octet rule. So that is why they are trying to get into so many different types of the what? Relationship. Okay. So now let's talk about different types of the relationship. So I did talk about this. These are called the noble gas, helium and neon, because they have their shell full. They fulfill the octet rule. However, the hydrogen, carbon, oxygen, sodium, they do not have their outer shell full. So that is why they are looking for relationship. Okay. So now how many different types of the relationship they can have, we are going to talk about that. But before that, let's see how much you remember. What subatomic particles determine the mass of an atom? Huh? Proton and neutron. Very good. What subatomic particles determine the charge of an atom? Electron and proton, because electron has negative charge and proton has which charge? Positive charge. What is the relationship of the octet rule and the chemical stability? If they have the full valence shell, they are happy. So they are stable. Okay? Okay. So now let's talk about all the different types of the chemical bonds. So for example, the strongest is the covalent bond, then ionic bond, then hydrogen bond, hydrophobic bonds, van der Waals bond. So when we say covalent bond, so let me tell you something very interesting. So if you are actually studying chemistry today, you probably would have learned that ionic bond is the strongest bond. Since you are studying biology, in the biology, covalent bond is the what? Strongest bond. Okay. So why we are going to talk about that. But for now, just understand that the covalent bond is the what? Strongest bond. Covalent bond, when we say covalent bond, is sharing. What is this? Sharing. And when we say ionic bond, this is transaction. This is what? Transaction. And when we say hydrogen bond, these are kind of follow through. We will talk about that. So now let's talk about the ionic bond. So we know that when we say sodium, sodium has how many electron? 11 electron. So 2 on the first shell, 8 on the second shell, 1 on the last shell. So what does that mean? To fulfill the octet rule, what do they have to do? They have to give out 1 or take 7 or receive 7. Do you think receiving 7 is easier or giving 1 is easier? Giving 1 is easier. So sodium is going to give 1 electron. Sodium will give 1 electron. So now we know that sodium has how many proton? 11 proton, right? If they give 1 electron, how many proton they will have, how many electron they will have left? 10. If they have 10 electron and 11 proton, what is going to be their charge now? They will be positive. Very good, because they have more proton than the electron. So what does that mean? This is transaction. Sodium is giving out 1 electron and turning into what? Turning into positive ion or cation. So remember that from now on, positive ion or cation. So now chlorine has 17 electron. 17 electron. That means in the first shell they have 2, second shell they have 8, last shell they have 7. So to fulfill the octet rule, how many electron? They need 1 more electron, right? So now when sodium is trying to give 1 electron, chlorine will be like, I want that electron. So chlorine take that electron. Now chlorine has how many electron? 18 electron. If chlorine has 18 electron, what is going to be the charge of the chlorine now? Negative, and we call it anion. So this positive and negative ion, now they have that transaction, give and take. Someone gave something and someone took something, and now they have the what? Transaction. Because of the transaction, what do they have to do? They have to stay together, right? They have to stay together and make a relationship. What is the name of that relationship? Ionic bond. What is the name of that relationship? Ionic bond. Because before they make the bond, they turned into what? Ion. Positive ion and the negative ion. Now they have that relationship, right? Yes or no? Clear, everyone? Okay, good. So now I want you to understand this ionic bond. If you think about that, this is almost like that transactional relationship. Like once upon a time, probably like maybe long time back, man used to earn, and female used to stay at home and do the household work. And now they have the transaction, right? Okay, I'm gonna provide the money, you are gonna do this for me. So now they are staying together in a very good relationship, right? Long time back, that used to be a very stable relationship, right? But nowadays, it's not that strong anymore, because now both male and female actually what? Work, and they both actually share the resources instead, right? So now let's talk about the sharing, covalent bond. So when we say covalent bond, what is happening? There is sharing is happening. So here, both both parties have the what? Resources to offer. Now they are actually sharing the resources together. Okay, so they can share 2 electron and result in single bond. They can share 4 electron, result in double bond. They can share 6 electron and result in triple bond. However, this sharing is not always the what? Happy sharing. When you share something with somebody, do you think it's always a happy sharing? Not always. Sometimes it is, sometimes it is not, right? So now let's talk about it a little bit more with the analogy. So when we say, so just think about a couple, they have one car. Okay, if they have one car, both of them work and both of them has to use the car. Now probably wife is a nurse and work night shift, and probably the husband is an engineer, work day shift. Okay, so what is happening? They are using the car, both of them are using the car, one in the day, one in the night. They are happily sharing it, there is no conflict. That's a what? Happy sharing. Okay, when there is happy sharing, that happy sharing can happen between the what? Elements as well. When they have the happy sharing, we call it non-polar bond. What do we call it? Non-polar bond. What if they do not have the happy sharing? So imagine another scenario where there is a couple, they have only one car, but that car is actually what? Can be shared by both of the husband and wife, but both of them work 9 to 5. So what do you think is going to happen? There will be conflict. But there is no way out, because they still have to share it anyways. But there will be definitely conflict, because this is not equal sharing. Even if you think about 5 days a week, probably husband can use probably 3 days a week, or maybe wife can use 3 days a week. It's not still equal sharing. Whenever there is no equal sharing, what will happen? Do you think they're gonna be happy in their heart, in their mind? They're happy? They're not happy. So if they're not happy in a relationship, what they're gonna do? They're gonna fight, and also they're gonna be kind of open for other relationship, even though they are not gonna tell each other, right? Like, I'm not happy, so let me see if I can find someone else outside. Exactly, that is what happening in the chemical reactions as well. So the covalent bond can be how many types? Polar and non-polar. When we say non-polar, what does that mean? They are sharing the electron equally. Like the CH4, carbon need 4 electron, hydrogen need 1 electron. So carbon is sharing with 4 hydrogen 4 electron. Okay, so what is happening right here? This is the happy sharing. They are very happy with each other. So this is non-polar bond. However, if you think about these, like oxygen and oxygen can also make bond, that is also happy sharing. Nitrogen and nitrogen can also make bonds, that is also what? Happy sharing. This carbon dioxide is also happy sharing, they are equally sharing the what? Electron. Okay, now let's talk about the polar covalent bond. One of the most important polar covalent bond present in the what? Very important molecule in our body, we call it water molecule. Do you know 60 to 80% of our body is made up of the water? Yeah. So water is a very important molecule in our body, and water does not have a happy relationship. They are not equally sharing the what? Electron. So what is happening here? So oxygen is slightly more electronegative than hydrogen. What does that mean? That oxygen has more attraction toward the what? Electron. If they have more attraction toward the electron, it's almost like that. If you think about couple is sharing the car 5 days in a week, 9 to 5, they are not equally sharing. Probably one is sharing 3 days in a week, another one is sharing what? 2 days in a week, something like that. So exactly like that, your oxygen is sharing the electron more. They have more attraction toward the what? Electron. That is why even though they are in a relationship, they're still slightly what? Electronegative. And hydrogen is slightly what? Electropositive. So what does that mean? They are in relationship, but they are still open for other relationship. Is it clear? That is why the water is also called universal solvent. So whatever comes inside, they would grab it. They would love it because they are always looking for another relationship, even though they are in a relationship. Does it make sense? Yeah. Okay. So now let's talk about another type of relationship, what we call the hydrogen bond. So when we say hydrogen bond, what is happening? In one water molecule, we have this oxygen, which is what? Slightly electronegative. These hydrogens are slightly electropositive. So what does it mean? If you put another water molecule, they also have the what? Electropositive hydrogen, which will be attracted toward the electronegative oxygen of the other molecule, and this electronegative what? Oxygen will be attracted toward the other electropositive molecule, other electropositive elements from the other molecule. So does that make sense? So that is why they are making another relationship between this, among these water molecules, that is called the what? Hydrogen bond. That is called the what? Hydrogen bond. That is the reason when you sprinkle the water, what happens? You will see after sometimes those drop of the what? Those drop of the water molecule will come together and make one bigger drop. Why is it happening? Because they have that attraction to stay together. Does it make sense? So due to the hydrogen bond, actually all these water molecules are staying together and making the what? Surface tension, so that other animals can actually walk on that. Okay, even there is attraction with that water molecule to the molecule of the cockroach as well. Like not cockroach, any other molecules. Okay, that is called the surface tension. Okay, so we kind of talked about the what? Ionic bond, covalent bond, and also talked about the what? Hydrogen bond. So now let's talk about the some like weaker bonds like van der Waals forces and the hydrophobic interaction. So when we say van der Waals forces, that is non-polar molecules, that is happening in the non-polar molecules, and electron orbiting nucleus briefly unevenly distributed. So what do we see? In the orbital, in the shell, the electrons are not distributed like evenly. They are so many different, they're dispersed, right? So what does that mean? Due to that position of the electron, they can have slight what? Positive or negative at this different site of the what? Molecule, and that could also produce some very weaker bond like van der Waals bond. Okay, so now let's talk about the hydrophobic interaction. Do you remember whenever we were talking about the phospholipid bilayer of our cell membrane? So the lipid and lipid are actually facing each other. Yes or no? Yeah, right? So that hydrophobic, the lipids are what? Hydrophobic. Those hydrophobic molecules, because they do not like water, they are gonna what? Try to make bond between them. That is called the hydrophobic interactions. Okay, so let's see. Could an ionic bond form between two cation? No, because positive positive do not make bond. Positive and negative make bond, right? What type of bond is formed between two oxygen atoms? What type of covalent? Polar or non-polar? Non-polar. They are happily sharing the electron. Is molecular oxygen non? Yeah, I already asked you the question. Is carbon dioxide polar or non-polar? Carbon dioxide, non-polar. They are happily sharing the electron. How about the water molecule? Water molecule is polar. They are in a relationship, but they are not happily or equally sharing the electron. So what does that mean? It means, they are looking for more relationship. So the part 2 is biochemistry. Before I talk about biochemistry, I want to make sure that you have understood